Okay, so today we're going over proofs. So proofs are a pretty big part of geometry in that we're explaining like how and why, like last class where we had to write out the steps to solving each equation. And so the way formal proofs are written is they always have a given and then a definition, property, postulate, or theorem. So given is the if part of a conditional statement. Prove is the then part, or what you're asked to show. So if these don't make sense yet, you'll see when we get to doing a few of these, but these are just the definitions to come back to. Alright, all these terms are ones that you will have to know for the test and for the proofs. So reflexive. When you see a reflection, what do you see? Yourself, right? So reflexive is just something equal to itself. So think of reflection if that helps you. And so an example would say if you have A, which is our given, if A, then A equals A. Seems really basic, right? So all you have to remember is just to pair that word in your mind. Reflexive goes along with A. A equals A. Alright, symmetric means they're equal when they're switched. Do you guys, do you know the word symmetry? Some people do. So if you know the word symmetry, it means that symmetry means it's exactly the same. So like if I drew a heart and it was a symmetric heart, which this isn't, but we'll just pretend, and I draw it in half, a line through it, each side is exactly the same, right? But they are opposite to each other, like it's flipped over. So it just means it's still equal when it's switched. So symmetric is if we have A equals B, then B equals A. So again, it's a basic thing. We just have to remember to pair the word symmetric with when we flip it around. Okay, you all know distributive, right?
Yes.
So that one's pretty easy. We just say if we have 3x plus 5, then that also equals 3x plus 15 once we distribute it. Who knows what a substitute is? Yeah, a replacement. You have substitute teachers all here. If I have to stay home because I'm sick or something, you'll have a replacement teacher in here, a substitute. And so that's all it means in math is when you see substitution, it's just if we have A plus B equals 5 and A equals 3, then we can put the 3 in the place of A and do 3 plus B equals 5. And I'm going to use capital B because it can look like a 6 sometimes. Alright, so transitive is a word you may not have heard before. Do you know the word transfer, though? Transfer means you take it from one place, put it to another place. And so transitive is a word that probably you might need some study to make sure you know that. And it just means we replace an entire side. Okay, so substitution is when we take one thing and put it into the middle of the equation. Transitive is when we replace an entire side. So if AB equals CD and CD equals EF, then AB also equals EF. So it's logical. If these two equal each other and these two equal each other, well then these equal each other too. We're just in our proofs putting the word to it, saying that's what we call transitive. Alright, and then we just have our math terms. So if we add, so if I have x plus 5 equals 10, and I'm sorry, that needs to be a minus. If I do x minus 5 equals 10, then x equals 15. So it was a x minus 5. I add 5 to both sides to get x equals 15. Subtract. If I have x plus 10 equals 20, then I subtract 10 from both sides to get x equals 10. Multiply. If I have x divided by 3 equals 15, what does x equal? Anyone? X equals 5, right? But the math that happens to do that is, no, not 5, 45. Yeah. So the math that happens is that I multiply times 3 on both sides to get it to 45. And then last, if I have 4x equals 16, then x equals 4.
What does that say? The 4x right there? Is that 4x?
If 4x. Okay, so this is called a two-column proof, where we put our statements here, and then the reasons, which would be all those words, the postulates here. And so I'm always going to start with my given. So it says if 7 equals A and 7 equals B. So my if part is always the given. So my givens are 7 equals A, 7 equals B. So when you're building your two-column proof, you always start with that. So whatever your if statement is, always goes in the first box. 7 equals A, and if I have a second, that goes in my second box. 7 equals B. And the reason for those is just given. Okay, they gave it to me. It was in my if statement. And it asks me to prove. Your proof statement is always going to be in your last box. And so that would be A equals B. And so all we had to do here is fill in my two givens, proof statement, and then what word would I put here? So prove is what I'm doing, but my word I put here has to go from these words. So which one? I took the A from here and the B from here. Which one would that be? Yeah, I could say substitution or transitive. I'm going to choose transitive because it is a whole side. There's nothing else on that side that I'm doing. So that's transitive. All right, on here, the given is 3 parentheses 2x plus 2 equals 30. That's given. And then my proof, I'm trying to get all the way down to x equals 4. So this one didn't give me enough to fill in every statement. What do you think I'm going to do in these in-between statements? Solve it. What would my first step in solving it be? Distribute. So I'm just going to write distribute or distribution. And I do the math. So 6x plus 6 equals 30. What would you do next? Subtract, because we have that plus 6 there, so subtraction. And so I do minus 6 to get 6x equals 24. And what's that last step to get me to x equals 4? Divide. All right, so on this one, did you have 1 or 2 givens here? We had 2. So we have the A, B plus 2 equals 45, and we have A equals 3. All right, what comes next? We're going to distribute, but first we're going to take the a equals 3 and put it into the place of there. So do 3b plus 2 equals 45. So when you have two givens like this, usually substitution is going to be in there, either substitution or transitive. Alright, now we do the distributive that someone told me. So 3b plus 6 equals 45. What comes next? Subtract and then divide. I heard both of those. So subtract 6 from both sides. 3b equals 39. And then we divide, or division, to get b equals 13. So you just solve it out step by step and give the words for it. For those of you who are really still struggling with the equations, on the actual end of unit test, this part of it actually has all the statements, and you just have to match up the reason for it. So that's something that you, as long as you can match up the reason for it, you should be doing well. Alright, this one mixed up a lot of people, but it was actually easy when you got it, right? What's my first statement? Yeah. So if we have AB, which is our given, then AB equals AB, and there was a typo there. These should all technically have the line over them, but programs often don't like us adding those in. So if we have all of those, what's the reason for that? Reflexive. Alright, what is my given here? X over 4 equals 12, and I'm asked to prove x equals 48. It's a really nice, just 2-box thing, so I just copy those down. So given, and what is my next reason? Multiply. Or multiplication. I don't care if you write multiply or multiplication. The technical term is multiplication. Alright, what's my given in number 3? This part, right? So x 8 minus 3 equals 4. Then I'm asked to prove 8x minus 3x equals 4. And so after my given, what is my reason for that? Distribution, right? And if you're solving this problem by yourself, you might choose to go ahead and do 8 minus 3 first before multiplying, but because this is what they asked us to prove, is the distribution. Alright, and last one. So we have our given 3x minus 8 equals 19. What do you do next to solve this equation? Add 8 to both sides to get 3x equals 27. And last step, divide.